Good evening. In today's session, I am going to explain you some more problems from the chapter System of Particles, especially from the topic Moment of Inertia, which are given in the previous JEE main. Let us move on to the problems based on that topic. See here, read the problem carefully. Radius of gyration of a hollow sphere about this axis, about any axis passing through the center of the sphere. For a hollow sphere, moment of inertia is I1 is equal to 2 by 5, for a hollow sphere it is 2 by 3 mr square. That word is very important. It is given as a hollow sphere. And moment of inertia of a cylinder of equal mass about this axis shown. In general, if this is a cylinder of length L, mass m, about this axis, moment of inertia formula is mr square by 4. If r is the radius of the cylinder, mr square by 4 plus ml square by 12. If you consider this cylinder as a thin rod, for a thin rod about an axis passing through the end point perpendicular to the length is ml square by 12, right? And this becomes the diameter of the disc, because this is a solid cylinder. About the diameter of the disc, moment of inertia is mr square by 4. So, for a cylinder about this axis, this is the formula for moment of inertia. Let us carefully substitute the values given. So, I2 is equal to, mass of the cylinder is given as same as that of the hollow sphere. Radius, diameter is given as 2r, so radius is r. So, this is mr square by 4 plus m. Length of the cylinder is given as 4r here. 4r square becomes 16r square, ml square by 3, ml square by 3. So, here let us calculate the moment of inertia. If you take that mr square as a common factor, 1 by 4 plus 16 by 3. So, mr square into LCM is 12, so it is 3, 4 16s are 64. So, moment of inertia of the solid cylinder about this axis, I2 becomes equal to 64 plus 3, 67 by 12, 67 by 12 mr square, and hollow sphere moment of inertia is given as 2 by 3 mr square. So, radius of gyration for the hollow sphere is square root of 2 by 3 r, and for this cylinder about that axis shown, it is square root of 67 by 12 r. So, you are asked to find the ratio of the radii of gyration. R and R gets cancelled. It is 2 by 3 by 67 by 12. This gets cancelled 4 times. So, this is a root of 8 by 67. So, here he has given like this, root of 8 by x. What is the value of x? In place of x, we have the number 67, hence the correct option is third option. Okay, move on to the next problem. Match the list 1 with list 2. So, moment of inertia of a solid sphere of radius r about any tangent. So, A is solid sphere of radius a about any tangent. Its moment of inertia is 2 by 5 mr square plus mr square. It is 7 by 5 mr square. From parallel axis theorem, we find out. So, this is I is Ig plus mr square. For a solid sphere, moment of inertia is 2 by 5 mr square. 2 by 5 mr square plus mr square is 7 by 5 mr square. And the next one given is moment of inertia of a hollow sphere about any tangent. This is a hollow sphere, I is equal, this is I1, let us take this as I2. So, this is hollow sphere 2 by 3 mr square plus mr square. So, it is 5 by 3 mr square. And the next one is given moment of inertia of a ring about its diameter. Moment of inertia of ring about its diameter, that is mr square by 2. And the fourth one is moment of inertia of a disk about any diameter. Moment of inertia of a disk about any diameter is mr square by 4. So, 7 by 5 mr square for 1 second. So, this or this. For B it is given as 1. For C let us check. C mr square by 2. So, mr square by 2. For C it has to be 4. So, first option is correct, because in this option it is given as 3. So, this is wrong. So, first option, but they are the values. So, it is very important to learn moment of inertia of all the objects about an axis passing through the center or natural axis, and about any other axis you can find I using either parallel axis theorem or perpendicular axis theorem. That is one very important area from which we are going to get one question in JEE Main. Now, moment of inertia of a square plate of side L about an axis passing through one of the corners and perpendicular to the plane. This is a square plate of mass m, side length L. We are supposed to find out the moment of inertia of this plate about an axis passing through one of the corners and perpendicular to the plane, like this. So, if we need to find the moment of inertia of any object about any axis not passing through the center of mass, we should think of parallel axis theorem. So, parallel axis theorem states, suppose if this is a rigid body, we want to find out the moment of inertia of this rigid body about this axis, which is very obviously not passing through the center of mass. Then imagine an axis parallel to the given axis and passing through the center of mass. Its moment of inertia of this body about this axis is Ig, and if r is the perpendicular distance between them, then I is equal to Ig plus mr square. That is the parallel axis theorem. So, here if this is the axis about which we need to find its moment of inertia, we have to imagine an axis passing through the center of mass parallel to the given axis, like this. So, about this axis, moment of inertia is ml square by 6, because for a square lamina, moment of inertia about an axis passing through the center perpendicular to the plane is ml square by 6, and this distance is L by root 2. So, I is equal to Ig plus m L by root 2 whole square, L by 2. So, if you take that ml square as a common factor outside, LCM is 6, 1 plus 3, 4 by 6, or it is 2 by 3 ml square. So, answer is the fourth option. Okay? Now, look into this problem. A solid cylinder of length 8 centimeters. So, a solid cylinder of length 80 centimeters, mass capital M, radius 20. Calculate the density of the material if its moment of inertia about this axis, which is parallel to the natural axis, is given. You are supposed to find the density. How do you find out density? density is equal to mass by volume of the cylinder. And for a cylinder, volume is pi r square h. So here, so it is pi r square h or L, where L is the length of the cylinder. Now let us do this problem carefully. Moment of inertia of this solid cylinder. Let this be a solid cylinder, and we want to find out the moment of inertia of this about this axis shown. And this is at a distance L by 2, where L is length of the cylinder given. So very obviously this axis is not passing through the center of mass. So if you think of parallel axis theorem, this is Ig, perpendicular distance is given as L by 2, I is equal to Ig plus m L by 2 whole square. Moment of inertia of a solid cylinder about the natural axis is m r square by 2 plus m L square by 4. Right? Now let us find out its moment of inertia substituting the values given. So I is equal to mass, I am taking it as a common factor outside. Radius is given as 20 centimeters. So radius is given as 20 centimeters. If you convert that into meters, 0.2 meters. Length is given as 80 centimeters. If you convert that into meters, 0.8 meters. So here m r square is 0.2 into 0.2, m r square by 2 plus L square is 0.8 into 0.8 divided by 4. So this gets cancelled 0.1 times, this gets cancelled 0.2 times. So here if you take that 0.2 as a common factor outside, m into 0.2 into 0.1 plus 0.8 is 0.9. So that is I. So I is given as 2.7 kg meter square. So 2.7 is equal to m into 2 into 9 is 0.2 into 0.9 is 0.18. So here it becomes m is equal to this divided by 0.18, implies m is equal to 270 divided by 18. So 9 gets cancelled 30 times and here 2 times. So this is 15. So mass is equal to 15 kg. That is the mass of the cylinder. So we have to find the volume of the cylinder so as to find the density. So volume of the cylinder is pi r square L. So find out, see here, this is pi, r square is 0.2 into 0.2 into length of the cylinder is given as 8. So here density is equal to 15 by pi 2 into 2 into 8, 10 power minus 3 goes to the numerator, 10 power 3. So here let us do the calculation part carefully here. So this is 15 into 10 to the power of 3. Approximately this, okay, so this is 16. So 1 by 6, it is 15. So here I am just doing the calculation approximately because options are farther, we can pick up the answer very quickly. So approximately to 16 and this 15 roughly. So 2 pi's are 1 by 3.18 into 2, roughly take it as 6 divided by into 10 to the power of 3. So it is 10 square, you take it outside. So it is 10 by 6. 10 by 6 is 16 approximately 15, 6 are 9, 1.5, 6 are 9, around 1.5 into 10 square. If you do it perfectly, we are getting it as 1.49 into 10 to the power of 2. So, here from this you can do the approximation, because you just look at the options, they are very apart. So, in that case you should not waste too much time in doing the calculation too accurate, because approximately also we can arrive at the answer. Now, look into this problem. Figure shows two solid discs with radius capital R and small r. Okay, mass per unit area is same for both. What is the moment of inertia of the bigger disc about an axis passing through the center perpendicular to the plane, and smaller disc about any one of its diameters lying in the plane? Look here, moment of inertia of the bigger disc about an axis passing through the center perpendicular to the plane, that is mr square by 2, and moment of inertia of the smaller disc about any of the diameters around the diameter lying in its plane, that is m small r square by 4. You are supposed to find the ratio of these two. So, I1 by I2 is equal to capital M by small m, capital R square by small r square, this goes to the numerator, into 4 by 2, that is 2. Okay, now you have to replace this m. See here, they have areal mass density. Mass per unit area is same for both. So, mass is proportional to area. As area of a disc is pi r square, mass is proportional to area. So, capital M by small m becomes capital R by small r whole square. So, from this concept, I1 by I2 is equal to how much? 2 into r, m by m is r square by small r square into r square by small r square. So, the answer is going to be 2r to the power of 4 is to small r to the power of 4. So, this is the correct answer for that problem. Okay? Now, move on to the next problem. Look here, moment of inertia of a circular disc of mass m, radius r, about x, y axis in its plane. This is a circular disc. Moment of inertia of this about x axis is I1, about y axis is I2. I1 will be equal to I2. And moment of inertia, they have given it as Ix, Iy. Let this be Ix and this be Iy. Okay, Ix and Iy are equal. Moment of inertia of this disc about an axis passing through the center perpendicular to the plane. It's given as, say, z axis. So, that I3 or Iz is equal to Ix plus Iy. So, very obviously, Ix and Iy are equal but not equal to Iz. What is given in the assertion is the respective radii of gyration above all the three axes will be the same. If moments of inertia are different for the same object about three different axes, very obviously the radii of gyration are different. They cannot be equal. So, assertion is wrong. Reason: a rigid body making a rotational motion has fixed mass and shape. Actually, that is a correct statement. Instead of saying it as a reason, it's another statement given that rigid body has fixed mass and shape, that is correct. So, assertion is not correct, A is not correct, R is correct. That is the right choice for the problem. Move on to this next problem. 4 equal masses are placed at the four corners of a square of length L. Moment of inertia about an axis passing through A and parallel to dB. So here I am writing that square. Okay, so let me draw the square here. This is the square, and four particles of mass m each are placed at the four corners. And here you are supposed to find the moment of inertia of this square about an axis passing through the corner like this. And it is mentioned that it is parallel to this line. Okay, so about this axis you are supposed to find moment of inertia which is parallel to the line dB, that is the diagonal. Now look here. Moment of inertia of system of particles is m1 r1 square plus m2 r2 square plus m3 r3 square, so on. Right? Here, as this particle is on the axis, its perpendicular distance is 0. So it doesn't contribute anything to moment of inertia. Now, the perpendicular distance of this particle from this and perpendicular distance of this from this is nothing but it is equal to the distance of each corner from the center of the square. So this is L by root 2, this is L by root 2, and this diagonal length is root 2L. So here its moment of inertia is 0, m2 r2 square, m into L by root 2 whole square, m L square by 2 plus m into L by root 2 whole square, L square by 2 plus m into root 2 L whole square. So ml square by 2 plus ml square by 2 is ml square plus 2 ml square. So the answer is 3 ml square. So this is the correct choice for that problem. Move on to the next. Look here. Four identical solid spheres, each of mass m, radius r, placed with their centers at the four corners of a square of side B. So let us consider a square, and at the four corners of a square, four solid spheres are placed. So here there is one solid sphere, another solid sphere, another. Four identical solid spheres of mass m and radius a are placed at the square at the four corners of a square of side A. Moment of inertia of the system about one side of the square whose axis of rotation is parallel to the plane of the square. Moment of inertia of the system about one side of the square where the axis of rotation is parallel in the plane of the square. So we are supposed to find moment of inertia of this about this axis. See here, we can directly say we have four spheres. So for four, see, I'll tell you the shortcut at the end. First I tell you the general method. Moment of inertia of this about an axis passing through the center. It is 2 by 5 mr square. It is mentioned they are solid spheres. So m, radius of each sphere is given as a, ma square. Square of side B, this is not A, that side is given as B here. Okay. So moment of inertia of this solid sphere about this axis is 2 by 5 ma square. Of this 2 by 5 ma square plus moment of inertia of this about this axis, parallel axis theorem, 2 by 5 ma square plus mb square. Ij is 2 by 5 ma square plus r, perpendicular distance between these two centers is or between the axis is b, mb square. For this also it is 2 by 5 mr square, that is ma square plus mb square. So altogether we will be getting 2 by 5 ma square, 2 by 5, 2 by 5, 2 by 5. So we have 4 into 2 by 5 ma square plus 2 mb square plus mb square, 2 mb square. So, it is 8 by 5 ma square plus 2 mb square. This is the correct answer for that problem. Actually, when force, if that is the situation, we can directly go for just 4 isolated spheres, 4 into 2 by 5 mr square. Then, if you treat them as particles, you have to find out moment of inertia of the particles about this mb square plus mb square, that is 2 mb square. So, just it is 8 by 5 mr square plus 2 mb square. Straight away you can answer that problem. Okay. Now, move on to the next problem. Moment of inertia of a hollow cylinder of length. Here answer is given wrong. So, hollow cylinder of length 30 centimeters with inner radius R1 is given as 10 centimeters and outer radius is given as 20 centimeters. About its axis, if the axis is not mentioned specifically, if they say natural axis or its axis, we consider it as a natural axis. So, moment of inertia of a cylinder in this case is like this. There is a hole across its length, right. So, inner radius is given as R1 and outer radius is given as R2. So, moment of inertia of that about this is moment of inertia of that cylinder is exactly similar to moment of inertia of an annular disc about an axis passing through the center perpendicular to the plane. So, because this cylinder is made up of number of annular discs arranged like that. So, moment of inertia of an annular disc becomes m into r1 square plus r2 square by 2, that is equal to m into r1 square plus r2 square by 2. So, here the radius of a thin cylinder of same mass about a moment of inertia is also I. Suppose if there is no hole, just if its radius is r, then its moment of inertia becomes mr square by 2. So, same mass m and m gets cancelled, from that r is equal to root of r1 square plus r2 square implies r is equal to root of 10 square plus 20 square. So, r is equal to 10 root of 1 square plus 2 square, it is 10 root 5. Actually, this is the correct answer given. It is 10 root 5 centimeters. It is printed wrong by mistake. Okay. Now, move on to the next problem. Look here. Moment of inertia of a solid sphere about an axis parallel to its diameter. For a solid sphere about any axis, moment of inertia is 2 by 5 mr square. About any axis passing through the center, moment of inertia is 2 by 5 mr square. See here, about an axis parallel to its diameter at a distance x. Look here. So, let us consider this as Ig. About any other axis parallel to the diameter which is at a distance x, from parallel axis theorem, it is Ig plus mr square. Here it becomes I is equal to 2 by 5 mr square plus m x square. This is a constant factor. So, when x is equal to 0, this is just 2 by 5 mr square. After that it increases. So, this is wrong, this is wrong. When x is equal to 0, it is given as 0. This is the correct option for that problem. Okay. Now, next one. Moment of inertia of a rod. First one. moment of inertia of a rod, length L, mass M, about an axis perpendicular to the length passing through the midpoint, that is ml square by 12. For A, ml square by 12. For 1, this option is not correct, this option is not correct. So, either C or D, because to eliminate this is given as same. So, let us check for C, that is C. Moment of inertia of a rod of length 2L, mass length 2L, ml square becomes 4L square, about an axis perpendicular to the rod passing through the midpoint, ml square by 12, where L is taken as 2L here. So, this becomes ml square by 3. For C, ml square by 3, that is second, 2. So, for C, 2, this one. So, for this is the correct answer for that problem. See here, and let us check for B, that is moment of inertia of a rod of mass M, mass 2m, length L. So, 2m passing through one of its ends, 2m L square by 3. So, for B it is 2 ml square by. So, for B it is 4, for C it is 2, for D moment of inertia of a rod of length 2L, mass 2m. So, mass 2m, L square is 4L square, perpendicular passing through one of its ends, 3. This is 8 ml square by 3, that is 1. So, option C is correct for that problem. Move on to the next problem. Look here. Moment of inertia of a cylinder of mass M, length L, radius R, about an axis passing through its center perpendicular to the axis of the cylinder is given like this. If such a cylinder is to be made for a given mass of a material to have minimum possible moment of inertia ratio of L and R. So, here let us do this problem carefully. Moment of inertia of a cylinder of mass M, length L, about an axis passing through the center perpendicular to the length. Let this be a solid cylinder. So, passing through the center perpendicular to the length. So, moment of inertia formula for this is mr square by 4 plus ml square by 12. Here actually they gave the formula also. For such a cylinder, what is the ratio of L and R so that the moment of inertia is minimum. So, let us take the length of the cylinder as x times the radius. If you substitute here, I is equal to mr square by 4 plus m, L is xr, ml square is x square r square by 12. So, let us take mr square as a common factor outside, 1 by 4 plus x square by 12, right. Now, this is the moment of inertia, m is constant, but r depends on the value of x. Now, let us see. Actually, volume of a cylinder is constant because density is constant, mass is constant, volume has to be constant. So, pi r square L. L is taken as x into r. So, volume is equal to pi r cube x. This is constant, this is constant. So, r cube is inversely proportional to x, or r is inversely proportional to x to the power of 1 by 3, implies r square is inversely proportional to x to the power of 2 by 3, or I am substituting that over here. I proportional to r square proportional to x to the power of minus 2 by 3. Because r square is proportional to inversely proportional to x power 2 by 3. This, if you take that to the numerator, x to the power of minus 2 by 3 into 1 by 4 plus x square by 12. See, to have moment of inertia minimum, its derivative with respect to x must be equal to 0. That is the condition. Let us take its derivative. If you expand this, I proportional to x to the power of minus 2 by 3 by 4 plus x square into x to the power of minus 2 by 3 is 6 minus 2, x to the power of 4 by 3, 4 by 3 by 12. So, di by dx is equal to, if you differentiate this with respect to x, 1 by 4 into minus 2 by 3 into x to the power of minus 2 by 3 minus 1 becomes minus 5 by 3 plus 1 by 12, derivative of x 4 by 3, x to the power of 4 by 3 minus 1, 1 by 3. This is equal to 0, implies 2 gets cancelled 2 times, minus 1 by 6, or if you bring this to the other side, if you equate this to 0, you will be getting 1 by 6, x to the power of minus 5 by 3 is equal to 4 by 12 into 3, x to the power of 1 by 3. So, 6 gets cancelled 2 times, 2 times. See here, if you take that to the other side and this to this side, 3 by 2 is equal to x to the power of 5 by 3 plus 1 by 3 is x to the power of 6 by 3, that is x square, implies x is equal to square root of 3 by 2. That is what we got. What is x here? This one. X is nothing but x is equal to the ratio of L and R. So, you are supposed to find the ratio of L by R, that is x, it is equal to square root of 3 by 2. So, I will stop here for today. I will continue with some more problems in tomorrow's class. Thank you and bye-bye.